Hello, thank you for joining this session. In this session, we will talk about application integration patterns for microservices in a serverless world. My name is Rohini, and I've been working with cloud technology since over a decade now, and I've been with AWS for last so many years in different roles in different geographies as well. I do create tech content and I work with the AWS community here in India and in neighboring countries. So if you want to be in touch with the community and what's happening in the AWS space, do check out my social media and do reach out to me and be connected. So, coming back to our topic for today, my goal for this session is to give you a quick understanding of some of the best practices of moving from monolith to microservices and then discussing the application integration patterns with serverless on AWS. Also, we will share resources for you for more deep dive and hands-on if you need after the session. So during the course of the session, if you have any questions, please feel free to add those in the chat and we will be happy to answer those questions. So the first things first, monoliths are okay. Starting with a monolith is often the right choice because it allows you to do fast development in an early stage and you don't need to design the entire process boundaries ahead of time. A well-designed monolith can be scaled horizontally and broken apart later if needed. And depending on the type of organization that you are in, you may never outgrow the scaling capacity of a well-designed monolith. However, as your business will start growing, you will face certain challenges with the monolith. Like as the demand for your application increases, the inability to scale the individual components in a monolith will make you to over provision for scale and meet the demand. The tight coupling between these different components will make it difficult to deploy regularly. And the technical debt that will be accumulated over time will make future development very difficult. And this is why customers move to a microservices driven architecture. In microservices, it makes it easier to build and scale large applications. Each service is tasked with one thing and doing it right. It has the most relevant data model and infrastructure to support it, making it easier to scale individual services independently. As your development team grows, microservices can keep your development velocity high, and it's much easier to do than to just wait for one huge change that you want to make in an application because you can now make more iterations and learn faster. Although each service does one thing, as a whole, they combine to provide a full suite of functionality to users. And in a well designed microservices architecture, if any of the individual microservices is not working, then the other parts of the application will still continue to function. So, a lot of customers ask this common question as to how do I get started with this decoupling? Now, trust me, it takes months and years to actually migrate from a monolith to tens or hundreds or even thousands of microservices, depending on the complexity of your application. Some customers have big teams that are capable of starting with most complex part. But if you are just starting with it, I suggest you start simple. These are two strategies here. Now, there are two strategies here. First, implement new functionality as services. And second is extract the services from the monolith itself. Look for capabilities that are fairly decoupled from the monolith, that don't require changes to many client facing applications and that are currently using the monolith, right? And possibly these services or microservices, the possible microservices, are not using any data store either. Here, you should aim for validating your delivery approaches, upscaling your team members to learn building microservices and the minimum infrastructure that is required and how you're going to build these services actually. Remember to decouple capability and not code. And this is very important. Understand your application architecture and break it down by different capabilities or domains and functionalities and features, whatever you may want to call it, and break them down. Don't look for code based separation like I have 10 classes and there will be two that these two will become microservice. It's a very bad practice. You can also look for capabilities that change very frequently and that are very important to your business. These could be better candidates as you can quickly showcase the benefits and be able to iterate on these microservices at a rapid pace of innovation that you want to drive. Do not create microservices that are dependent on the monolith. Then instead of having microservices, you would just end up with two different monoliths. Ensure that microservices can run independently with the right circuit breakers in place. This also leads to a common discussion versus for macro versus microservices. How micro a microservice must be. Now, you don't want to just create a microservice for just crowd operations, create, read, update, delete. You want them to be able to function very independently of each other. If that means that right now you want to club 2 or 3 microservices into one single macro service, that's fine too. You can break this macro service into a microservices in the future. For example, in a retail application, it may be possible that your cart, your checkout, and your payment services are tightly coupled and it needs a lot of work to break them down individually. So you could break these 3 into a macro service and then be able to scale and over time maybe refactor them individually. So, an important question that a lot of customers ask is, okay, now that I have these different microservices, how are these different services going to communicate with each other? There are two important mechanisms in which the services communicate with each other. The primary mechanism is APIs. These are the front door of your microservices. And your APIs collectively are like the phone book for your microservices, and it gives you a pretty organized view of your architecture. So, a common way to loosely couple these different services is to expose an API following the REST architectural style. The REST APIs are based on the architecture of the web and provide loose coupling between the different communicating parties. Hence, while REST APIs are common and are useful in microservices design, REST APIs tend to be designed with synchronous communication, where a response is required before proceeding with other requests. So, a request coming from an end user client can trigger a complex communication path within your services landscapes, which can effectively add coupling between the services at runtime. After all, this is why there are mitigation patterns like circuit breakers in the first place. REST APIs can also add some of the heavy lifting to your infrastructure. I've listed a blog or a parent blog in the resources section later to the presentation, which details out a little bit more on what are the challenges when it comes to using REST APIs for all your different microservices. So the second common integration pattern is using events, which are changes in the state or updates. Event-driven architectures can improve your scalability, fault tolerance, and agility by reducing the dependencies between processes and teams. Let's dig in a little bit. We talked about decoupling components so that they can scale and operate independently. And for this, it is very important for them to have asynchronous communication. Events give you this great decoupling benefit. Here, the producer sends a message to the consumer and proceeds without waiting for the response. And that's what asynchronous communication is. So, but do note, now the producer and the consumer take a dependency on this middleware stack, which must also scale to demand and be resilient to failure. Hence, managed services, you should use managed services that take care of most of these complexities for you. So routers abstract the producers and consumers from each other. So you can publish, or a producer can publish messages to the router, continue doing what it was doing, and the consumer can just consume it from the router and process that data. The producer does not need to know who the consumer is, and the consumer does not need to be dependent on the producer in this case. While there is a dependency on the middleware stack, and you should have a uh, scalable and resilient and reliable middleware stack, we do give you some options in this area. Now, there are two types here. There is event routers, and we are talking about event stores. Event routers at AWS include Amazon SNS, which is a simple notification service It's a fully managed pub/sub, publish, subscribe, pub/sub messaging service. A SNS topic is like a broadcasting station. You can publish messages to the topic, and anyone interested in these messages can just subscribe to that topic. Whereas EventBridge is a serverless event bus that connects your different application data that is coming from your application or different SaaS applications and even AWS services. On the other side, event stores act as buffers. They hold on to events until the consumer is ready to use them. So you can push messages into a queue and you can retrieve messages from this queue. And messages queues operate so that any given message is consumed only by one consumer or only by one receiver. Even if there are multiple receivers that are connected to it, one message will always be consumed by one receiver. At AWS, we have Amazon SQS or Simple Queue Service, which is our serverless event store or queue. Now, both these or all of these serverless, fully managed message, queue, and topic services scale to make your demands and provide simple, easy to use APIs. You can use SQS and SNS to decouple and scale microservices, distributed systems, and serverless applications and improve your overall reliability. Now, overall, serverless is an operational model that spans across multiple categories. When we say serverless, we mean its removal of that undifferentiated heavy lifting that is server operations. And in addition to the integration services that were mentioned before, you could also use AWS Lambda, which is a serverless compute service that lets you run code without provisioning or managing any servers. Now, Lambda automatically scales your application by running the code in response to each event that is happening. So you can set up your code to automatically trigger for over 200 AWS services or SaaS applications, or you can just call it directly from any web or mobile application. So in our case, where we have the producer, the message channel, and the consumer, you can use AWS Lambda for your producers and your consumers as well. In case of consumers, the Lambda function will automatically be invoked whenever there's a message put into that SQS queue. The same applies to serverless architectures implementing the pub/sub pattern, which we will discuss in few of the slides later. Lambda functions will be executed directly when they have been triggered by an SNS message. So whenever you the producer puts in anything in the messaging channel, it can automatically trigger a Lambda function. The function comes up, starts processing based on the code that you've written, does its work, stores that data if it has to, or gives the response back, and carries on. So what are these different application integration patterns that you can form with just few of the services that we discussed today? So let's look at some of them. There are two things that you need to know. First is message exchange and message channels. In this way, the first thing is in the message exchange is one-way messaging. Look at the first diagram that we have. In this messaging pattern, a message producer or the sender sends out a message to a messaging channel, and it doesn't expect or want any response from whatever the processor or the receiver is consumed with. So some examples of one-way messaging could be, I want to do a data transfer. Once that data transfer is done, just send me a notification, or if it's done, I don't need to know about it. So that could be just one-way messaging that you want to do. On the other hand, there is request and response messaging. In this, a message producer or the requester sends out a message, for example, a command to instruct the responder to do something, execute something, like encode this video for me. And once it's done, just send a notification on what the execution you've done, or send a response of where this file is located, where you have stored this file. So in this case, a requester expects a response for each message that the consumer has received. So in this case, what you need to send is two things. First is the return address. Like where does the responder or where does the consumer, once it's done processing, how does it reply back to the requester itself? So it needs to send the reply to address for the consumer. So a requester will always send this information to the responder. The second information that the requester must send is the correlation ID. This correlation ID is something that the requester will understand. Okay, I sent a message, you processed it, and you sent it back. Now, what this message, this processing that you've done is for which message? They need to be correlated, right? That this was the request and this is the response for it. That's the reason you need something called as a correlation identifier, which obviously the responders echo in their responses. The second is the message channels. Now, this also is 2 points. The first is a point-to-point channel, and the second is the published subscribe channel. The first one, a point-to-point channel, is usually implemented by different message queues. Notice here we have a queue. Now, message queue operates so that any given message that can be consumed by only one receiver on the other end. So the queue ensures that once only consumption is happening with that message. And the messages are often buffered in this queue so that whenever their consumers are available, when there are enough consumers are available, they will consume it over a certain amount of time. Even if there is no consumer there on the other end, the message will still persist in the queue. So for example, when you begin creating applications, it may happen that at a particular point in the day, you could see that there are only 3 messages in the queue. So 3 receivers or 3 consumers can process this data. But you see a busy time in your day and 30 messages are in the queue. You can then take a consideration. Do you want to add more consumers to start processing that data? Or do you want to still continue with 3 and process this data as and when the consumer is available? So it helps do that load balancing. It helps you flatten the peak at a point. In the second one, the publish subscribe, you use something called as a topic. And this is where you would use something like SNS as a topic. Here, you send messages into this topic. And as soon as the message is put into the topic, all the consumers will be notified that there is a message in the topic. There is also a facility for filtering. I will talk about it later in the presentation. However, if there are no subscribers on this end, the message, once it's published, and if there is no subscriber on this end, for example, it's not working, the message will be discarded. So the durable subscriber pattern describes an exception where messages are kept for a while in case a subscriber is offline. So you do have a way of setting a setting that do keep the messages for a while in case the subscriber is offline. And this method or this pattern is used when multiple parties are interested in certain messages. And this pattern is also called as a fan out pattern. Okay, let's look at these patterns, or the combination of these two, the channels and the exchanges we just saw. So the first thing is you could look at point to point as a channel, but we'll look at the one-way option. In this option, you send a message to the queue and the receivers are consuming the message and there is no response expected. Right. Similarly, we have an option of a return channel. Now here, the requester sends the message into the request queue and the responder sends the response back into the response queue. Now here, the requester also provides the return address or the reply to address and the correlation ID. These two are definitely important. When do you use this? When do you use point-to-point channels? These are often used in loosely coupled messages transmission through 2 common use cases. The first is it supports horizontal scaling of your messages processing on the receiver side. Remember that it doesn't depend on the load, right? So it does depend on the load. So the more messages you have in your queue, the more receivers you can add or remove. So your queue can scale in and out based on the messages that you have in your queue. In this case, the queue acts as a buffering load balancer. The second one is that it can flatten the peak loads of messages and prevent your receivers from being flooded. It's not like there are messages that are coming from your clients, but it is not going to overwhelm your receiver end. And you can scale in and out depending on your requirements, or depending on your cost requirements as well. Now, Lambda, using Lambda here comes in with a lot of benefits because you don't have to manage the compute environment for the receiver. And you can use the event or the push model instead of having to keep polling and checking if is there a new message, is there a new message. Whenever there's a message in the queue, Lambda function will come up, start processing it, and go back to sleep. So it's that easy when you use it in a serverless fashion. In the pub/sub one-way pattern, there is often notification style use cases that we discussed before. So publisher sends out a message and doesn't care who is interested in that message. So in the pub/sub request response, it's beneficial when it is important to communicate with multiple parties that do some kind of work in parallel, but all the responses can also be aggregated afterwards. So in this one, it's just one way, right? So you just send the message, you don't care about it. But in this one, you would definitely be having some kind of response that is coming back from all your receivers. So a publisher produces a message and sends it to a topic, right? So the first thing, a requester will send it into a topic. This will be consumed. But notice that when it is sending the response back, it is not in a topic. It is sending a response back in a queue. So why do we do this? Why do we want to send it into a queue? Let's look at it a little bit in detail. Here, when all of them are receiving the messages, the same message from a topic itself, they are going to be sending it back to a queue. And this pattern specifically is called as a scatter-gather pattern, which is a composite pattern of pub/sub and point-to-point messaging channel. Here, the aggregator component consumes the individual messages that are coming into the queue itself. And what they do is they try to aggregate or they will try to process it. And once that is done, it will give it to the final processor. So this is the reason you put it in a queue, because you don't want to lose that data. You want to keep that data persistent, and you want to be able to consume that data by maybe one or more aggregators. You want to consume that data, process it, do some kind of processing on that data, and then pass it to your processor. If you want to keep these two components of aggregator and processor separate, you can then again add some kind of messaging in between them to make them more decoupled. In this case, you could also have the requester being the same, requester being the aggregator and the processor, so that all these components fit into one microservice itself, like we saw in the previous example. Now let's take a real world example where you would use this. For example, let's look at some of the examples from Wild Rides. It's a fictional application that replaces your traditional taxis with unicorns. Okay, so that's why it's called as Wild Rides. The first one is definitely to allow the customers to initiate request for quotation. Like, I want to take a ride. Tell me, unicorns, tell me what are your special offers, and I will choose based on the special offers or the best prices that you all are providing me. So what in this case it does is a customer sends the right details that I want to go from this destination to this destination, and I will ask for quotations from all the unicorns in my vicinity. And then I can choose the best offer. So the architecture looks something like this, where the backend will use the scatter gather pattern that we just talked about to publish the RFQ to the unicorns. In this case, the end user using the app or the website sends a request to the requester. The requester, when they receive a request for quotation, they will add it into a topic. Now, there could be multiple services in the backend that could be talking to multiple unicorns in the backend as well. So these services will then get a notification, there's a new message. They will talk to the unicorn riders. They will try to negotiate, hey, give me your best offer. Once they give the best offer, they'll put it back into a RFQ response queue. And then, as this will again be an aggregator or a processor for us, so we'll start understanding what is happening. So what do you see in this architecture? There is message exchange. So there is request response. Yes. The correlation ID and the return address is important because it is a request response that is happening. So in this case, you would send the ARN or the Amazon resource name of the SQS queue in your response. Then you add a topic because it's a broadcast, right? All these services are waiting for a broadcast. So you add that. Then there is a queue. which is like a buffer. So all whenever someone is giving a code, that could be within a minute, that could be within few seconds, all of those go back into the queue, and the queue acts as a buffer in this case, right? So everything, all the data will be in the queue itself, and the requester will start consuming from the queue itself. And finally, what are we talking about? This is called as a scatter-gather pattern. Let's take one more quick example of a ride completion. So I've given the quotation, I've found my unicorn, I've taken the amazing unicorn ride, and I now want to uh, finish my ride. And I want to check, okay, what's the bill amount? Does it add into my loyalty service? And there are other things as a customer I want to do. So once you finish your ride, there are multiple services that should be invoked internally. Let's look at the architecture. So here, once you finish your ride, that you've the end unicorn has said, I finished the ride. I say, yes, the ride is over. That should be a ride completion topic in the backend. Now, a lot of times, what customers would do is they could also have, instead of a topic, they could have an HTTP location, HTTP API in front of all these subscriber services as well. So here we are doing message exchange one way, right? And what we are saying is, because it's an SNS topic, you could also add an extra filter. Now, where would a filter work? For example, I want to know these extraordinary rides that are happening, like beyond a certain amount. Someone has paid so much amount for our services, or they've traveled very far in the world. I want to know about these extraordinary rides, and I want to give these customers some extra benefits or some offers. So for that, you could have something like an extraordinary ride service. So in this case, you could add a filter that, hey, if a topic message is beyond this filter, only then wake me up. Otherwise, I'm not coming, getting up. So you could also do that, right? So this is your simple one-way exchange. But let me give you a scenario. What happens if one of these, for example, let's say the loyalty service, what happens if the loyalty service has some issue, the code is not running, or there's some exception that is happening, or it is just offline for maintenance? It will not get that message. So the customer loyalty points will not be updated. So there is a potential of missing these topic messages. What do you do in this case? It's very simple. Add a pattern called as topic queue chaining. So we'll add a queue in front of all these different services. So in this case, whenever there is a topic, that topic has a message, the topic will push it to different queues. So even if one of our services is not running, it will still, once it comes back, it will go and check the queue and start taking those messages and start executing. Secondly, remember we talked about using queue as a load balancer. The queue will now start taking all these messages. So for example, if the loyalty service is very slow, then the other service that you have is customer accounting service. It's okay, because the messages are going to be persistent in the queue, and the services can function at their own pace. So it helps you flatten the peak loads. Your customers are going to be happy. You can then take decisions on how you're going to be distributing the load itself. So that's the another pattern that you want to look at, is topic queue chaining. So using this, you can use the simple fan capability, but then you can also add the characteristics of a queue and use that for helping our poor customers who want to book unicorn rides and make it a little bit of better customer experience. So that's the talk. For a deeper dive into these topics of queues and topics and how do you use them in conjunctions, if you want sample code, definitely use these two resources. There is a blog series that discuss all these things in detail with some sample code as well. So the first link is for that. And the second link is for the hands-on workshop. So the Wild Rides is an entire workshop. If you want to play around with these things and do these by hand and want to make mistakes and learn from them, definitely use the hands-on workshop. So that is my time. Remember, loose coupling is always better than lousy coupling. Thank you for attending this session. Feel free to connect with me on these social media handles. Go build.